Wonderful, everybody. Welcome to the August 14th working group meeting for Karpenter. Let's start off with some project updates. Does anybody have anything that they wanted to report on? I don't think I saw a manual for a node overlay in here or Samuka for static capacity. Any other projects folks want to talk about? Nope. All right. I can move on to the RFCs then. Non-drifting template variables for user data fields. I think I saw Max, you were here if you wanted to talk about it.
Yeah, thanks. So I have this RFC open for adding, non-drifting template variables to the user data field in EC2 node class. So this is for AWS only. So I'll give like a brief background about this. So like any change to the user data field like triggers drift. And for our case, that's not ideal because we have some sensitive, well, not necessarily sensitive, but rotating data that we put in the user data field that rotates, every so often. And problem is that this data, we can't store it in somewhere like AWS Secrets Manager or some other like external service. It has to live in the cluster. So there's no real way to be able to, I guess, update that user data field without, manually changing it. And that change will cause the drift. So I just have this RFC here open that adds this new field, or I propose to add this new field called user data variables. And it's sort of just a field where if you add a key map or key value list, it'll just do a simple like string replace in the user data that you provide. And that field will be undriftable. So, you can change that freely and that won't cause the, drift. So yeah, more details are in the RFC. So if anyone has any questions, please let me know. But also feel free to leave some review in PR as well.
I think one thing I'm wondering, so you mentioned that, so you have like an architectural requirement that the data needs to be stored in the cluster. Is it not possible for a process in the node to read like a secret once it joins the cluster, or is it required for even being able to do node bootstrap?
Yeah, it's required to do the node bootstrap. Um, so a little bit more to like, I guess the general architecture. So we're using Core OS nodes, and the the bootstrapping for that doesn't use like cloud in it. It uses this thing called ignition config, and it and I guess the contract for ignition is that you can't like use startup scripts or like anything like that to be able to pull things from other places. So we can't necessarily like inject that secret somehow into the bootstrapping phase and pull it there. So yeah, it's a little hard to be able to do that. Does that answer the question?
Yeah, it answers the question on the requirement. I'm just wondering, that almost feels more like a functionality gap there that would be good to fill.
Yeah, that's fair. I know it's possible for, so I've asked some Chorus people like that is possible to pull credentials and stuff directly from AWS, like the AMI is able to do that, but it can't like pull, from anywhere else, as far as I know. So I guess would it be reasonable to like ask CoreOS people if that's a gap that we might want to fill instead?
I mean, I know that some Omni families in general are pretty opinionated on not having startup scripts. I think Bottle Rocket is like that, where you can't run any, you just can't run arbitrary code in the user data. I could be wrong about that, but I was looking into that recently, and it didn't seem like you could. So I'm guessing that there is reasons for Omnis to not want to support that kind of like on startup script running thing. I do wonder if there isn't a different Kubernetes way to solve it. Like we want to spitball the ideas right before we agree to make a feature. So I wonder if you couldn't do like a config map that um, whatever on the node needs access to this accesses, like maybe it's written onto a volume or something, or like um, you could write it onto the node in different ways, I think. But if none of those ways meet your requirements, or if none of them are like doable, then I don't see a way to do this other than with some kind of like templating for your user data. Although
So
that's not ideal for a number of ways.
yeah, I completely understand that point. As far as I know, so for our particular use case, that the token that is rotating is basically a bearer token that the configuration grabs the actual configuration from some like offline or not offline, but just some external server, right? So it's it's a little, I'm not exactly sure how like if Ignition supports that like we can inject files before bootstrapping, and maybe I need to dig further into that, and that would certainly solve the issue. But I've asked that question basically, and the answer was sort of like, no, we can't do that. So uh, yeah, I know there's a separate way to solve this for our particular use case, is to you know, just look at the user data and like have our own like carry patch fork to check, if this particular field changes uh in this unmarshaled JSON, and then if it doesn't, then don't drift. But like that's not really ideal. So um yeah, thanks for the feedback. I might need to do a bit more research, but as far as I know, like this cannot be solved much other ways without changing something somewhere.
Yeah. My only other question then is like introducing these user data variables seems useful for a lot of other, like just from structuring your user data perspective. But I think a lot of people might be surprised that they're non-drifting. Like I could see someone writing a bunch of node classes where all they do is change the variables for different classes, and then they would expect a drift update to happen. Um, so I'm not sure how once we get further into this RFC process, I feel we're going to need some way to communicate that to the user, um, to say like so that way they know these are non-drifting variables, or they can maybe configure. I don't know if I love the idea of them having to configure that they're non-drifting, but that's going to be something we should probably talk about.
See, there's a couple hand raised. I think Almiko, you raised your hand first.
Ah,
Yeah. So, like aside from the differences between Ignition and Cloud Init, because I mean, I guess for people who aren't familiar, Ignition is one of the big other ways to launch, instances and configure them aside from Cloud Init, and it's very mature at this point. So it's unlikely that we'll be able to make large changes to the data model for Ignition. But I think even outside of that and the specific issues here, um, there's a really valid reason for having data that might be part of the node class that you don't want to generate a drift from, right? So there might be metadata, like in this case, we're talking about changing like a token or a secret or something like that. And that may not impact the nodes at all. Like the nodes may not need to be recycled for that change. So I think I totally agree that, and I'll put this on the review. I was just looking at it, like user data variables is probably hiding that the side effect of like, okay, yeah, this is going to be a non-drifting variable that you're putting in there. But I think being able to specify non-drifting variables could be very powerful, for users who might have metadata that needs to change that doesn't necessarily predicate a change in the underlying instance. So it doesn't need like an instance recycling. I'll hand it over to Garvin.
Yeah, I guess I also run, I guess I'm coming here with a slightly different angle where I am using custom ambi type, and I do notice there are problems where like for example, right? It's the core function of like Karpenter's like being able to transport labels and tains from node pool all the way down to the node that's gonna end up starting. But with custom AMI, it drops all that. And I think there is a desire for custom AMI to still do certain functions, such as passing through some of these higher level variables down back to the underlying user data, and maybe templating whatever EC2 no class plus no pool such that certain variables can then be passed through into the underlying user data can also then open up the doors like, okay, we have this template for user data. Here's some variables in addition to labels and tains that we want to pass through to the underlying user data, and we can make those optionally driftable or whatnot. That way we open up slightly more such that like it's not just the Linux, I mean the Amazon AL2 or whatever that is supported. It can support custom a little bit better. And in addition to like having more flexibility in like defining variables in the EC2 node class that can then template into user data. Because right now it's just a blob, right? Like regardless of custom AMI or AL2 or whatever, it's just a blob for user data. If we can open up like more open-ended templating into the user data. I know we moved away from launch template directly, but open upping like templating for user data, it might open up flexibility for custom AMI, but also allow us to do certain things like driftable variables within user data.
Yeah, no, there's definitely that would address quite a few pain points. I think one of the biggest ones I've seen a lot is you to use custom AMIs correctly, if you're configuring any kubelet settings, you have to make sure that they're configured on both Carpenter's config and in the kubelet.
Yes.
Otherwise, you have said scheduling simulation mismatches.
Yes,
So,
that's what we have to deal with every day.
yeah, yeah, being able to handle the templating for that, I think would be pretty valuable. And that's where I think if we can expand on all of these use cases in the RFC, this makes a fair bit of sense to me. I want to make sure we're just not hyper fixating on one particular use case, but it does seem like there is a very broad set of use cases that this addresses for both driftable and non-driftable, like templated fields.
I believe there was an older PR or issue for templating user data. It's like lost to the sense of time. I can try to find it, but it's
There's there's definitely an issue for it, or maybe I'm thinking there's an issue for templating tags, like being able to template tags based on node pool name, node class name, etc. And so I think that one might have also included like an ask for templating user data.
All right. Well, thanks for the feedback. Yeah, definitely. Please like add some comments to the RFC, and hopefully, if we can make this more generalized to not hyper fixate on my particular use case, but like solve lots of these other problems for other people, I think that would be definitely the best. So, yes, please, please, thank you so much.
Yeah, thank you for the RFC. Any other comments on this one before we move on? I see no hand raised, so we'll go on to the next one. Me selector term requirements.
So I'm trying to judge off username. I don't think the person who raised this is here. Please feel free to speak up if you are. Otherwise, I'll talk about this briefly. Okay.
Going once.
So yeah, I
Go ahead,
just wanted
Jason.
to get this on people's radar because I thought this was a pretty interesting RFC. So for those who aren't aware, like Carpenter basically has two different ways of doing AMI selection. You can select your own AMIs using like tags, AMI IDs, etc. And then you can also use the alias term, which the advantage of the alias term is, so if you say like alias AL2023, you get all of the different variants for the AL 2023 AMI. So you get the standard one, the one for supporting NVIDIA devices, for AWS's Neuron devices, etc. And Karpenter basically injects these requirements onto each of these AMIs to indicate if an instance type matches these requirements, I should choose to use this AMI. We can't support that same functionality for just standard AMI selection because the only information that we get from the Describe Images API is the architecture. So we pretty much just know, can it launch on an ARM64 node or an AMD 64 node? And like, that's kind of all we have available to us. So this RFC has a couple of proposals for basically being able to add that requirement semantic to existing like ID-based selectors, SSM-based selectors, etc. Basically as a way to minimize configuration. So like rather than needing to have separate node pools for all of these different types of AMIs, that way you can dictate which ones land on which instance types. You can have all of them in a single node class and use these requirement terms in the same way as alias to dictate which instance type gets which AMI. So this is something I kind of wanted to implement when we were originally doing alias, like ahead of Karpenter v1. So I was excited to see an RFC open for this. It wasn't something I think we had a strong enough signal for use case of at the time. But if anyone has any feedback, if they think that this would be valuable to them, please take a look at this RFC, leave comments. I think it proposes a pretty reasonable direction and gives us basically the ability to take our other AMI selector terms and bring them into parity in terms of capability with alias. So yeah, I think it's relatively valuable, but would definitely like to see other people's feedback for it.
Wait, sorry, I haven't read through. When we say alias, how we define an alias?
So alias is just an AMI selector term. So you can do like alias AL 2023 at latest, like rather than say ID or tags. And so our semantic for that, like what we do under the hood is we look at all of the different SSM parameters that are published for AL 2023 for x86, for ARM64, NVIDIA, Neuron, etc. Get all of those AMIs, and because we know what the requirements associated with those AMIs based on their SSM parameters are, we can then inject those in and make sure we're doing intelligent AMI selection based on what instance type we're launching. So like we'll always choose a NVIDIA AMI if we're launching a instance with a NVIDIA GPU.
Got it. Okay.
Yeah, I think all the way at the very bottom of this page, the requirements show up in the status, like AMI status. And I think we show an example of what the requirements look like with an alias versus without. So yeah, you can see like we have these requirements based on accelerator count, GPU count for handling selection for, in this case, NVIDIA Neuron devices.
Any comments, questions? Folks have any concerns? Seems like a pretty natural support, I think.
Yeah, I think I was convinced that it made sense in the RFC. The only weird thing is every field in AMI selector terms up until now has been to select an AMI. Like you have fields like tags, ID, etc. This is kind of related. It's not what AMI do you select, it's given this AMI I selected, which nodes do I schedule it to? So it's almost a little bit weird keeping it in the same bucket of fields. But I do think I was convinced in the RFC that it was the most natural place for it. And it did make semantic sense if you kind of just shifted your mindset a little.
Yeah. All right. So folks have thoughts, please leave comments, chat about it. Moving on. This one's from Ryan, if you wanted to talk about it.
Yeah.
Increasing the
So
registration timeout.
yeah, we're looking at increasing the node claim registration timeout from 15 minutes to 30 minutes. And this is just like a heuristic time that we expect the node to register in. And if we don't see it, then we delete the node claim and retry. And the reason for this is that like large scale, we expect this number to just be larger and we don't want to like preemptively delete and retry. I think there's also like other good reasons. For example, like AMI startup take a long time and stuff. So just wanted to bring this up and see if anyone had like any issues with it.
I have a PR to make the registration TTL adjustable rather than changing the default. I linked it on the Zoom chat. I'm trying to figure out like it would be good if you add your use case there too, but maybe worth getting there's some traction. But essentially, there's a PR open for this where essentially you can specify exactly what the timeout you want it to be, and rather than relying on the default, if there is a override, it would pick that and will change to that. Um, does that kind of fit your use case? Because like I think here we're trying to gather some information about like who else is using this, but then the PR is like the feed right there. Yeah. And it should be relatively flexible. It's just you can punch in whatever TTL you want it to be.
Yeah, I believe that should fit our use case as well.
Yeah, though I think so for this particular use case, we're still, correct me if I'm wrong, but the registration TTL field would be optional and we would still use whatever the default is, whether
Yes.
that's 15 or 30. I think the ask here is to bump the default to 30 because there are default use cases at the scales we're starting to run at that
I,
start hitting that issue.
I think
guess-
I
sorry.
don't know if that's a concern so much at the scales we're talking. I think the kind of customers that we're looking to support this for are going to be the type of customers that will be able to configure this value to whatever we tell them is the best. So I think this would suit our I do think this would suit the needs we're looking for. The question is just like timing. Do we want to bump the default and have this option, or do we want to? Because I know that there was some discussion in the actual issue itself of whether or not we just should bump the default. So I guess the question, we should have a configurable registration TTL. I think that would be a nice thing for customers to have. And the question is, should we also bump the default?
I
In my
guess
mind.
in my mind, the concern with bumping the default is now you wait a longer period of time before a node fails to register and it tries again. So like we're doubling that time now. Not that 15 minutes versus 30 minutes, like a huge, I think like, but then I think like if something has gone wrong and your nodes are failing to register, you're taking much longer now to realize something might be wrong. Um, or like that node just had like, it just came out bad. It's not a configuration issue. Now it takes 30 minutes instead of 15. Um, versus, so I'm not sure if it makes sense to change the default too much. If anything, I think the default maybe should be a little lower, but ignoring that, but like the failure is now much longer as you continue to extend the duration in which way you wait for. And I'm not sure if going the other way, like going longer makes sense, at least for my use case. And I'm not sure if for most other people, but I want it to fail actually faster rather than longer.
I'm curious, and this is not just a question for you, but kind of for everyone. How often do you see these intermittent failures versus like there's a persistent configuration issue either on the node itself or networking that is causing failure over and over again? Because usually, at least in my experience, when I see nodes failing to register due to like this TTL, we relaunch using the same node pool and the replacement also fails to register, and you're in that loop because there is some networking configuration or configuration on the node which is causing that reachability issue. I have occasionally seen intermittent failures like say just from a bad EC2 instance, but those have been exceptionally rare in my personal experience.
Yeah, I think you're right. I think majority of the time it's definitely a configuration issue. And I guess in that case, I'm not sure if churning more nodes or waiting longer to fail. I'm not sure which one is the better. It feels similar to me in terms of like you wait 15 minutes or you wait 5 minutes for it to churn again, or 30 minutes to churn again. But on the other side is the in the cases where it is actually a bad node, failing fast seems to be the appropriate. Unfortunately, the Karpenter stuff, there's no way to differentiate between the two, except for a timeout, right?
Yeah, yeah, from our
I
side,
think
I mean,
ideally that's the fix, right? The ideally is that we have a a better mechanism for determining when nodes will actually fail to launch, but we don't have
basically
that.
a backdoor into the instance to look at kubelet logs.
Yeah, I mean, yeah.
Do you have use cases where this number, we might want to vary this number by instance type? Because sometimes, GPU instance types might take longer to provision, at least in our cases. So we were thinking maybe it should be by instance type. And I don't know if instance type overlay, what are we calling this, is a good place maybe to customize it per instance type if we want it at all.
I think originally we talked about overlay, and the reason I didn't end up going that way is because it's not always tied to instance type. Like for example, let's say like you're running certain nodes that just takes a long time to bootstrap, regardless of GPU or not. It no longer kind of works if instance type because you now have like more than this instance type that's slow. It like at a node pool level, you can be like, I know that this set of nodes will come up slow because of particular configuration at like the node level. I mean, node pool level or the EC2 node class level, and maybe augmenting it with no overlay makes sense. But I feel like most of the time, like let's say GPU, it is usually under one node pool, and that way you can say all GPU under this node pool is going to take longer, so I'm going to change the configuration. Um, at least that was the logic behind moving it to node pool and not like overlay or something like that.
I think especially for
Yeah.
the initial use case of node overlay, I don't know if it makes sense to do that right away, but I could see that as like an eventual
Addition, yeah.
extension if you do have really interesting instances. Where you want to have a node pool that has like GPU and non-GPU in it, and then you're like, okay, well, for the GPU ones, I want it to take longer.
Maybe another quick
Yeah.
question. Right now, this default, is it provider customizable or is it a const that cannot be overridden by the provider?
I
I
don't,
think currently
don't
it's
think
a
so.
const.
Yeah, as a cons within the underlying core library, so it's not configurable by anyone. Well, unless you fork it, but yeah.
Right.
Yeah, which I mean, I don't think it would be, if there was a need, I don't think it would be controversial to allow providers to override this default, because I think it's reasonable to expect on different cloud providers you're going to have different registration times. So I think the 15 minutes was chosen as the reasonable upper bound for instances launched in AWS back when this was just for AWS, but now that we've opened it up, I don't see a reason why we would need to say every cloud provider needs to fall into this bucket.
Yeah, just wanted to echo what I've already heard, that there's a bit of a tension between fail fast, which is often useful, and yeah, allowing nodes to take a little longer. So it's a tough one.
Yeah, is there anything blocking? Are you just blocked on review, Garvin, for getting this change in?
Yeah, essentially. I just realized it had a merge for conflict, but I fixed it just now. So yeah, I'm just waiting for review.
Got it. Okay. So yeah, there was already consensus on the RFC.
Yeah.
Once this is reverged, we should be able to get in. Okay.
Yep. I guess to circle all the way back, like Ryan, is that okay? Like, is that a reasonable moving forward path rather than changing the default for now?
Yeah, I think that makes sense.
In fact, I think the whole reason why if I remember rightly, when we were talking about it earlier, Ryan, I think the whole reason you went with just dumping the default was we wanted to avoid surfacing additional config without going through the whole RFC process. So
Yeah.
since Garvin did it for us.
Yeah. Thank you very much.
Thanks. Cool. Any other questions on that before we circle back to you linked that there, perfect. Cool. All right. We're at the end of the community questions. Does anybody have anything open-ended they want to bring up? Stuff they want to chat about?
Yeah, I've got one, I guess, question. Let me post a link here. Yeah, so there's a PR in the chat. It's a very small change, but it'll affect the cloud providers. So I wanted to, since Alex is here and Mike's here, this change would basically raise the max instance types that could be passed to the create call on the cloud provider from 60 to 600. I think that the intent of this is to put the control back into the hands of the cloud provider on like how many instance types they actually want to consider at launch time. So I wouldn't expect for you to actually get 600, but I wanted to leave an upper bound on it just to not like fill up a node claim. But I wanted to see if there's any issues in the Azure cloud provider or cluster API or other ones.
I wouldn't imagine that there would be a problem. I mean, cluster API is built on top of all these other providers. So yeah, like if you think 600 is a good limit, like I can't imagine that, certainly cluster API on top of AWS is not going to go over that limit. And if it's okay for the other providers, it probably wouldn't be an issue for us either.
Okay.
Yeah, probably similar response here. I do wonder a little bit about the reasoning. Can you talk through, why you think that might be needed?
Yeah, so that limit in core was chosen because that's what we limited in the AWS cloud provider. So they're actually the same. We truncate on both sides in the AWS cloud provider and in core. We're looking at, because we've launched, a bunch more instance types, there's over 900 now. We're just looking at ways to increase flexibility in the calls. And so we were kind of like the AWS cloud provider is blocked at 60 because core truncates at 60 as well. So I'm not changing the AWS cloud provider yet. But eventually we would like to increase the AWS cloud provider to include more than 60 instance types to our launch API, which is Fleet, mainly for spot use cases where users want to be really flexible in their requests so they can get an instance that will run for a long time without interruptions.
Makes sense. Maybe another follow-up questions. Have you looked at the performance implications, like memory footprint implications? I assume they're not very significant.
Yeah, so in core, it actually doesn't matter because we already bin pack and schedule against all, and then we truncate. The cloud provider, at least for the AWS cloud provider, there's like a little bit more work to do. And then I look at the Azure one as well. It looks like you all are like sorting them and then taking the first one for price. So yeah, there would be some additional work, but it looks like it's pretty minimal.
Sounds good to me, especially since providers are still free to truncate further if needed.
Yeah, and I think that's what I would recommend to potentially, like if there is concern on this, I would implement the truncation in the cloud provider if there's like any concern whatsoever, just knowing that we're raising this field in core.
I guess I have a question. It's not specific to this, but it seems on theme with this and what we chatted about this earlier about the TTL. We have a lot of these hard-coded variables that may be provider specific within the core I think it's likely worthwhile for this to be, I don't know, extracted out into some common provider specific configuration with some sort of default so that Azure or a cluster API can just be like, oh, okay, I can just update these without like having the node pool default to some other variables or something like that. Because I think like, yeah, there are definitely use cases where like TTL may not make sense for 15 minutes for certain providers, or this max instance type doesn't make sense for some providers. And the provider have to look through all the code to find all these little things. It might be worthwhile just as part of the chores to like extract them out and put it somewhere common that any provider can override as they adopt Karpenter, if that makes sense.
Yeah, so you mean like when you instantiate the core controllers, like you pass in configuration to core or something on the cloud.
Yeah, because I think there's a lot of these small little things everywhere that I think makes sense in the beginning because it was this AWS, but now it's different. So it might be worth making it easier for a provider to understand and know where to look to adjust these things for themselves.
Yeah, I think that makes sense, or at least exposing all of these little consts that we have throughout all these magic numbers.
Yeah, it does
Well,
make
some of
sense.
them make sense, some of them don't, I think. I can think of the like consts for like max concurrent reconciles and stuff like that, where those kind of constants shouldn't be provider specific. Like, unless, I don't know, there's a cloud provider that does disruption very differently, but since all that logic is upstream, I can't imagine that that would be a use case. But I do think stuff like this, where like the barrier between the cloud provider and upstream, they're like where they're integrated, I do think it makes sense to get rid of these magic numbers.
There was also some discussion in the past around describing the provider contract, I guess, for lack of a better word. And maybe something like that, could be part of this, or maybe if we try to describe the contract, then these things will become, more obvious and just naturally emerge.
I think Mike has his hand up.
Yeah, that's like kind of what I was going to say, Alex. Like I opened an issue to start recording things that I was coming across as like provider contract kind of things. And I know we do have some documentation that talks about, the provider's responsibility and whatnot, but maybe we can continue just to use that issue and start like hitting all these magic numbers. If we can just start collecting them all in one place, it'll become really easy for us to start writing documentation where we just say, okay, let's just put all these. Because I agree, like as a provider trying to implement this stuff, like I spend a lot of time looking at the Azure and AWS implementations to understand how some of these things work and what I need to be doing. And, it's not a terrible experience because it helps me to understand how a lot of the code is written. But it does make it difficult sometimes to understand like why our provider is acting in a weird way. So yeah, I'm totally all for anything to increase the communications on that stuff.
And I think generally it will help collecting those in one place because all of these global overrides aren't really it's not a great library experience, especially from a discoverability aspect. I think right now the only codified like contract is the cloud provider interface. Being able to migrate a lot of this global configuration out of these individual packages and into a central place would go a long way in and of itself.
Something
I
else,
don't know how straightforward that is, but
yeah, I mean, yeah, that's the tough part, like making our constants.header file or whatever. But another approach we might consider, especially if these values have bearing on how the internals of Karpenter works, is we might consider making metrics that expose these as well. And while those metrics wouldn't be changing, it would give a really easy way for anyone who's running a specific provider to know immediately if that provider has like overridden some of these values or whatever.
Or when we change defaults, like with the max registration time, you
Right.
would at least notice that in your dashboards, like, oh, something changed when I upgraded to this version.
yeah, and
Right.
it's not like there isn't precedent for that. I'm pretty sure we emit the commit hash as a metric. So
Do you have the issue handy for the issue you've been using to describe the cloud provider
I
like
linked the
integration?
contract documentation in the Google Doc.
Ah, okay, perfect. Just want to make sure that's surfaced to folks.
No, do you have to refresh? How come it's not showing as a comment? Oh, I didn't send it yet. Okay. There you go. I think. Did it work? There you go. Oh.
Hang on, it's back.
Huh? How come it's not showing up? Oh, there it is. Okay, that was weird.
Okay, cool. Make sure that this gets put in.
And we need to
So
get
it's
Darren
easily accessible.
permissions
And then
stuff.
folks should feel free to use that. I lost it already. To document any of these things that come across. So this max instance types should probably link out to it. Cool. All right. Anybody have any other issues they wanted to talk about?
I'm just curious real quick. Brandon, you had mentioned you didn't want to totally take away the upper bound on max instance types. Is the rationale just like if you had a cloud provider which had hundreds of thousands of instance types and now suddenly we exceed the max that CD object size?
Yeah, that was kind of it. But I mean, realistically, that's not gonna happen because it's 1.5 megs, right? So you'd have to have like a really large node claim to breach that size. I'm open to raising it more, I think. Maybe to like an actual like max value that would take into account like ridiculously large amounts that but would also truncate it enough to where if there was a bug or something, it wouldn't overrun things.
Right.
600 felt like that because it's 10x the previous value, but I could see it raising higher.
Yeah, I mean, I think realistically for our use cases, 600 is plenty for flexibility. Um, yeah, I'm just wondering if we need it here or like I've also been wondering if we need to even continue injecting individual instance types into the node claim requirements to begin with, versus just continuing to constrain the resource requests and let the cloud providers recompute which instance types are compatible. Because that's kind of the experience of using standalone node claims. It is also going to be the experience of node claims using static capacity.
Yeah, I guess maybe selfishly, I like the instance types in the node claim because it's like a nice way. Yeah, like not because it's necessary, but because it's a nice way to see your flexibility set for a request.
No, that's true.
But maybe there's other ways to surface that though.
Sorry, could you remind me, is it going to be like after narrowing it down to say 60 from 600 or before that we capture it on the node plane?
It's after, so it'd be like today you'll only ever get 60 instance types in the node claim, and after this change you could get 600 in the node claim, and then the cloud provider could truncate it down further, but you'd still have the large set in the node claim.
So that might be a potential concern, right? I don't know if that's where the question started, but in a very large clusters with a very large number of node claims, just amount of storage consumed by those might be a concern.
Yeah, it depends on your like most of your node claims are not going to have 600, so it'd be in like very rare if even like possible circumstances that your node claims would have 600. They also don't take up much space because it's one line. It's like a small text segment.
Right.
Definitely something worth considering, though, I think, for that second bit.
Yeah.
For the actual raising to 600, doesn't sound like there are many objections. It's mostly like a why not higher kind of question.
Yeah.
Yeah, that's pretty much
Cool.
my only thought. 600 seems reasonable to start with, though.
Yeah.
Does anybody have any other comments? I don't see any hands raised. Going once. Going twice.
On this one, I do have a question about metrics and dashboards.
Amazing. We just keep going like this, we're never gonna have to stop the meeting, guys. It's great.
Maybe just a quick question since we started talking about the metrics and dashboards. I was looking for good dashboards for Karpenter. I know there are a couple maintained in AWS provider. I found a couple of dashboards that community started, and there is one set that looks really good, mostly because I think it's done kind of the right way, quote unquote, with the mixins. So it's basically dashboards as code. And they may not be perfect right now. I link to in the chat where we use it in our provider, or at least like can instantiate it in our provider. But those look potentially well enough done to be adopted by the community overall. They're not perfect out of the box, but because they're done as dashboards as code, they should be very easy to evolve. So I was wondering what you think about it, or whether there are other dashboards that people are using and find useful.
I
Yeah,
haven't run into any dashboards specifically that I've like used, but I do know that this is an outstanding question. I've heard this from some users where it's like, how do we do good good dashboard monitoring using Karpenter? And I didn't have a good answer, so I can give these a look. Has anybody else here used these? No? All right. Does anybody have any dashboards they have used?
We have built our own just because we couldn't find anything good. But I can try and take a look at these. It'll take me some time because I think I have to dump the JSON into my own Grafana and see.
Yeah, I think you make a great point, Alex, that this is something that we should probably have, that we should adopt some kind of like, here's the standard one. Here's the standard dashboard that like we think suits carpenters pretty well. I think that's something that I don't know if you've reached out to Aiden.
no, I
who-
haven't. I just noticed that, the way they're done, I don't know if you've seen this way of doing things like with Libsonnet, essentially kind of dashboards as code. It's a nice way because, editing the dashboards, like editing the blob of JSON is always a hassle, and, it's very hard to see how it evolves. So this seems to me kind of the right approach, and it's a good starting point, so potentially right for adoption, but I haven't talked to the author.
Wonderful. I'm checking hands. No hands raised. Anybody else got any comments about dashboards? All right. Sounds good. Any other issues? We've got 6 minutes left here. Going once. Going twice. All right. Thanks everybody for attending the Carpenter Working Group.
Thanks.
Thank
Thanks.
you.
Bye.
Yes.
Everyone.